Okay, so we just saw the Pythagorean theorem and we did a few examples with it, and we saw how it was proven. Now I want to show two direct, nice consequences from it. And these are two results you've probably seen before as well. The first is the distance between 2 points, and the second is the midpoint between 2 points. And we'll be using these formulas a lot during this class as well. So what I want to show you the distance formula, the distance from point x1, y1, and a point x2, y2 in the plane is the square root of the square of x1 minus x2 plus the square of y1 minus y2. Okay, and of course that's all over a square root. Okay, and we'll see where the square root, we're going to see where this comes from. It comes from the Pythagorean theorem, of course. Before I do any examples, just to show you how this follows nicely from the Pythagorean theorem, if we take this same line segment here and make a right triangle out of it, where we take a vertical line passing through this point and a horizontal line passing through this point, and they intersect at this point, we get a right triangle here. Because obviously, a vertical line and a horizontal line always intersect at right angles. And we can see that this third point here, this point has to have the same x-coordinate as this point. So the x-coordinate is x2. And these 2 points here have the same y-coordinate, which is y1. So we have the coordinate of this has to be x2, y1. And then we can find the lengths of the lengths of this triangle very easily. This is the difference y2 minus y1, and this is this distance has to be x2 minus x1. Okay. All right. So now we have we can use our Pythagorean theorem. A squared plus b squared equals c squared, where a is x2 minus x1 and b is y2 minus y1. So we get d squared is going to be x2 minus x1 squared plus y2 minus y1 squared. Okay, before we take the square root, we can change the sign of this because x1 minus x2 is the opposite of x2 minus x1, but because we're squaring that, the minus sign is going to go away. So we get d squared is going to be x1 minus x2 squared plus y1 minus y2 squared. Okay, again, because they differ just by a minus sign, and the square, when you're squaring it, goes away. And then we can take the square root of both sides. And we're done. And one thing, of course, we're not going to fall into the trap. The square root, we can't break this up into the square root of this plus the square root of this, because square roots don't act like that with sums. Okay. So that's where we use the Pythagorean theorem to prove the distance formula. So to prove the distance between the points 1, 6 and 2, 7, well, here's, our x1 will be 1, our y1 will be 6, our x2 will be 2, and our y2 will be 7. So our distance is going to be the square root of 1 minus 2 quantity squared plus 6 minus 7 quantity squared. Okay, and this will be the square root of -1 squared plus -1 squared, which is the same thing as 1 plus 1, which is 2. So the distance is going to be the square root of 2. Another example, we have when we get to this, we can obviously we don't have to write down what x1 and x2 and all those other things are. You can see the distance here would be the square root of -3 minus 5 . squared, and then 6 minus negative 1 squared. And so this is going to be negative 8 squared. And this is going to be 7 squared. So this will be the square root of 64 plus 56. Oops, rather 49. My bad. And then this should be the square. I believe it's the square root of 113. All right, so that's how the distance formula works.